Hey guys, Dibyajyoti here from The Fast Engineer. Have you ever wondered why does a bulb glow? But sometimes wires burn. Why does your phone charge safely? But a short circuit destroys everything. Is electricity controlled or dangerous? Today, I will show you the one rule behind electrical systems. This is Ohm's law. Let me teach you Ohm's law in just a few seconds with a simple story. A scientist named George Ohm did a basic experiment. He connected a 2-volt battery to a bulb and the bulb started glowing. Then he increased the battery to 4 volts and the bulb glowed brighter. More glow means more current. So from this, he understood something powerful. More voltage gives more current. So if we increase the voltage, current also increases. So current is directly proportional to voltage. And this simple idea is called Ohm's law. Now let's understand everything in detail. Electricity might look complex at first, but it's actually very similar to how water flows. Let's understand with a simple example. Imagine a tank filled with water connected to a pipe. In the first case, the tank is full and the pipe is wide. So water flows strongly into the bucket. In the second case, the pipe is still wide, but the tank has less water. So the flow becomes weaker. And in the third case, the tank is full again, but now the pipe is narrow. So even with full water, the flow is less. From these three situations, we understand something important. The pressure of the water pushes it through the pipe. This pressure is like voltage. As water flows through the pipe, that flow is called current. Now, when the pipe is narrow, it resists the flow of water. That restriction is called resistance. So more pressure means more flow. Just like more voltage means more current. But more resistance reduces the flow. And this is exactly how electricity behaves inside a circuit. Voltage is like pressure, current is like the flow, and resistance is the restriction. I hope it's clear now. Now that you understand the concept, let's quickly look at the symbols and units we will use. In Ohm's law, we use three main quantities. Voltage is represented by V and its unit is volt. Current is represented by capital I and its unit is ampere. Resistance is represented by R and its unit is ohm. So now that we know the symbols and their units, let's understand what Ohm's law is. It states that the current flowing through a conductor is directly proportional to the voltage applied across it, provided the temperature and the other physical conditions remain unchanged. So temperature and physical conditions should be constant. It explains the relationship between voltage, current, and resistance. In simple words, if you increase the voltage, the current increases. And if you decrease the voltage, the current decreases. But this flow is controlled by resistance. If resistance is high, current decreases. And if resistance is low, current increases. Let us write current is directly proportional to voltage. This symbol means proportional to. To convert this into an equation, we introduce a constant. That constant is called resistance. So we write I equals V by R. This capital R is the constant of proportionality and it represents resistance. Now rearranging this equation, we get V equals IR. And this is the standard form of Ohm's law. Now that we understand the equation, let's see how this works in a real circuit. Here we have a simple circuit, a battery, a resistor, and a connecting wire. The battery provides voltage. The resistor offers resistance, and the current flows through the circuit. We already know the main equation, V equals IR. But depending on what we need to find, we can rearrange this equation. If we want to find current, then I equals V by R. Current equals voltage divided by resistance. If we want to find resistance, then R equals V by I. Resistance equals voltage divided by current. So from one simple law, we get three powerful equations. But remembering formulas can be very confusing. So engineers use a simple trick, the ohms triangle. We just need to remember this. To find voltage, cover the letter V and you get I multiplied by R. So voltage equals current multiplied by resistance. To find current, cover the letter I. You get V divided by R. So current equals voltage divided by resistance. And to find resistance, cover the letter R. You get V divided by I. So resistance equals voltage divided by current. So with just this one triangle, you can remember all forms of Ohm's law. So now we know all the forms of Ohm's law, but engineers don't just use equations. They also visualize this relationship using graphs. For a material that follows Ohm's law, the graph between current and voltage is a straight line passing through the origin. This straight line tells us something very important, that current is directly proportional to voltage. Now let's look at the slope of this line. This graph is similar to the equation of a straight line. Y equals mx. This matches perfectly with our equation. We know that current equals voltage divided by resistance. I equals V divided by R. So here, if you compare, current behaves like Y, voltage behaves like X, and the slope M is equal to 1 over R. So in one simple idea, the graph, the equation, and the slope all tell the same story. Now let's solve a simple problem. Here we have a simple circuit. If the voltage is equal to 10 volts and the resistance is equal to 5 ohms, what will be the current? To solve this, let's use the Ohm's triangle. Here we want to find the current. So we cover the letter I and we get I equals voltage divided by resistance. Now substituting the values, I equals 10 divided by 5. I equals 2 amperes. So using the triangle, it becomes super easy. Engineers use this law to design safe systems. Without it, electricity would be chaos. So next time you switch on a light, remember it's not magic, it's physics perfectly controlled. So now you understand Ohm's law, but electricity gets even more interesting. If you have ever wondered why birds don't get electrocuted while sitting on a high voltage power line, watch that video next. It's on your screen right now. If you enjoyed this video, subscribe for more engineering secrets. I will see you in the next one.